Hey everybody, Mr. Odom here, and we're going to work out problems 26 and 28 from section 10.3. As always, make sure you got your pencil, composition book or notebook paper, and a calculator. The learning target for this video is I can find theoretical and experimental probabilities of an event. All right, so the bar graph shows the results of spinning the spinner 200 times. So there's your experiment. You just spun this thing 200 times. You want to compare the theoretical and experimental probabilities of the event. And what's the event? It is spinning a 3. So in theory, there are 5 different numbers on the wheel. One of them is a 3. So in theory, the probability of spinning a 3 is 1 out of 5, or 20%. What about the experimental probability? Well, I need to add all of these values together to get to the or the total number of times I spun. And I did that, and it actually told me in the problem, but I verified it by adding those up, and I got 200. Okay, how many times did the spinner land on a 3? It landed on it 39 times. So that would be my favorable outcomes. So 39 over 200, put that in my calculator, move the decimal point, I get about 19.5%. All right, so what can I say? Basically, I can say that the experimental probability is close to the theoretical probability, okay? Sometimes it's not, sometimes it is. The more times that you spin the spinner, the closer you will get to the theoretical probability, okay? So number 28, should you use the theoretical or experimental probability to predict the number of times you will spin a 3 in 10,000 spins? And just like I said above, you want to use the theoretical probability because sometimes you could conduct this experiment, and let's say out of 10,000 times, you landed on a 3 twice, okay? And if you landed on a 3 2 out of 10,000 times, that's going to give you a very small probability, okay? But the theoretical probability tells you that, hey, I should, out of 10,000 times, I should land on a 3 about 2,000 times, okay, in theory. So you want to use that theoretical probability when you want to make a prediction. And then use your experimental probability to see, hey, how close to the prediction will I get? Okay, that lets you know that your experiment is a pretty good one, okay? So that's all I have for that problem. And this is Mr. Odom, still. I'm still your math teacher, and I'm still out.